Good afternoon. You probably recognise me as a character from The Hitchhiker's Guide to the Galaxy. I've got my towel and I'm waiting for a lift from a Vogan transport which is coming through this solar system shortly before the Earth is destroyed. Consequently, I feel very qualified to talk about cosmology. I'm reading a book by Sean Carroll and it's about quantum mechanics, and he points out that there are several difficulties with understanding the way the world works. One is that according to the equations of quantum mechanics, it seems to demonstrate that there are multiple worlds. It's not just us here on Earth at the moment. Next door there's another Earth, and next door to that there might be another one and another one, and so on. And one of the reasons that's useful is because the other problem with quantum mechanics is it says that things like electrons, which we always thought were little spots whizzing around inside an atom, don't appear to be quite that. They appear to be more like a cloud. And when we take a photo of it, what we see is the electrons there. Because what seems to have happened is that cloud has coalesced into a point. However, there's no reason on Earth or in the galaxy why the electron should be at that point there, because it could be at that point there, or that point there. So if we put those two things together, this might be helpful, because if there were other people taking pictures of electrons at the same time, if you had your camera and you were working on a picture of an electron and it came out there, you wouldn't have to worry, because probably in a parallel world just quite close to ours, there would be somebody who was just like you taking that picture just like that, except that they would see an electron there, and in another world further on they might see an electron there. And that would allow for the fact that, as far as we know, when that electron coalesces, it could be in any point in our photograph. It could be anywhere. And what somebody very wisely said a few years ago is maybe that's true. Maybe it is everywhere. Not in our universe, because in our universe it's at a particular point, just there. But in their universe it could be somewhere else. And in their universe it could be somewhere else as well. Now, there's several interesting things about that. One is that these multiple universes may have been created when the Big Bang happened that created our universe. And I've seen a drawing somewhere where it shows a point creating a bang, and our universe like a balloon coming out from that point and expanding into space. At the same time, there's another balloon next to it expanding into space. At the same time, there's another balloon expanding. So these multiple worlds may have started with the Big Bang. But there's another theory, and that is that these multiple worlds are created when reality diverges. So when you go and measure your electron and you find out that it's there, another universe has to come into existence at precisely that point, so that that person in there can measure the electron and find it there. And then another universe has to split off as well. Now, the trouble with creating extra universes now is that it might need a lot of energy. You could create multiple universes when the Big Bang happened, because that was a huge amount of energy. But the idea that just because you're bent over your electron microscope and you're taking a picture and this thing's there, in order to make the equations balance, what has to happen is that immediately another universe splits off, so that the other you over there can find a point there, and the other you beyond that can find a point there. So at the point that you are taking a picture of this point, there could be an infinite number of universes being created. Now, where does the energy come from? Because we're not just talking about our world and our solar system and our galaxy. We're talking about all the other billion galaxies in this universe. What we have to imagine is that somehow, from somewhere, is created another universe without a Big Bang. without that point where something went and exploded into creating matter, what we're imagining is that a much more calm thing happens where you create a universe simply by measuring an electron. Would the universe do that? Would the universe bother to create 10, a dozen, 100 universes just to satisfy the fact that you're measuring an electron? Because even as we speak, there might be somebody in Australia who's measuring an electron, and even though we don't know it, we're suddenly being duplicated into another universe because we're all taken into this extra universe so that the electron that they take a picture of can be as varied as the one we've got. Now, where are we going to get the energy from to do that without a bang? It may be that there is some spare energy around, because another thing about quantum mechanics at the moment is we seem to have measured the universe that we live in, and it looks like there's some missing energy. It looks like that what we've got in this universe is only about 10% of what should be there. Well, maybe we can take a guess then. If 90% of the energy in our universe is missing, maybe that's gone to create another 9 universes. Maybe we can measure the amount of energy there should be and imagine that when the universe was created at the Big Bang, it split into 10 different universes which are parallel to each other. So wait a minute, that would mean that yes, we had multiple worlds, and if there was somebody like you taking a picture of an electron, then maybe in your world, in the world I know about, that's where you find the electron, and maybe in the universe next door they find an electron there, and then the one next door they find an electron there, and so on. The trouble with that is, you say, that would only allow the possibility of 10 points where the electron could be. But that's not true, is it? Because in our universe, when we look at that wave collapse and we find the electron there are infinite number of places that electron could be. It just happens to have landed up there. Just like in the universe next door, there are infinite number of places the electron could be, and it ends up there. Now, we only have 10 universes, so we only have 10 photographs. We only have pictures of 10 places where electrons are at. But in each universe, we had an infinite number of possibilities. And what we've done is created pictures of electrons in 10 different places. So surely that meets the criteria of having to be more than one, because we've got these multiple worlds. And that's what the equations tell us. And if you want an example of how that might work, I like to think about the fact that I live in Salford, which is quite close to Manchester in the northwest of England. And if I wanted to go from where I am now to the centre of town, the centre of Manchester, I could get a bus, and that bus would cost me £2.50 if I didn't have my travel card with me. And in order to get back from Manchester to Salford, I'd have to pay another £2.50. But the man on the bus might say, you know, if you want a return ticket, it's not 2 times £2.50, it's only £4. Well, that's fine, that's a bargain. Yes, but there's an even bigger bargain. For £4.50, you could get a day card, and that day ticket would take you anywhere in the county of Greater Manchester. And it just so happens that Greater Manchester has 10 boroughs, just like the number of universes. So that means I could use that day rover ticket to not only get into the middle of Manchester, but then to travel to Bury. Or I could go to Rochdale. Or I could go to Wigan. Or any combination of those. And that means that for my ticket, there are an infinite number of possibilities where I could go. But there's no compulsion. There's nothing on the ticket that says, after you finish with Manchester, you must go to Bury. And after that, you must go to Rochdale. And you must go to Wigan. It doesn't say that. And don't forget Stockport, because everybody forgets Stockport. Your ticket entitles you to go to Stockport too. You don't have to be there. I can go on my day journey and come back, and you say to me, where have I been? Well, on this journey, I've been to Manchester and I came back. That's all I did. But next week, I might say, I went to Manchester, I went to Bury, I went across to Rochdale, and then I came back to Manchester, and then came back to Salford, because there's an infinite number of possibilities. But on any particular day, if it just so happens that I only went to Stockport, that doesn't mean that that ticket's invalid. That doesn't mean that I've ignored the infinite possibilities. It means I've chosen. I've chosen a destination. And that electron, maybe it doesn't choose, but it happens to be at that place in our universe, even though it could be anywhere. And in the universe next door, it happens to be in that place, even though it could have been anywhere. And I think that means we've satisfied the requirements. The requirements are that any time a waveform collapses, that electron could be anywhere. Yes, it could, but it just happens to be at one particular place. But in the universe next door, it could be in a different place. And that means that all those possibilities have been covered, except that it's only turned out to be one result. Just like when you throw a dice. You don't throw a dice and all the numbers come up. There's only a particular set of numbers at that particular time. And that would be all right if there were only 10 universes, surely. But another thing that might be a necessity is that those universes are actually quite close to each other. So instead of that vision of a big bang and universes going off in all directions, that's very difficult to understand, because that would mean that you, looking at your electron here now, would somehow have to coordinate with the you that's not on this planet, in this solar system, in this galaxy, in this universe, but is way across our universe, and then way across the universe next door, and then in the galaxy where the other you lives. Wouldn't it be better if those 10 universes were all on top of each other? We can't see them, and I'll go into that. They're not visible, but it means that you only have to communicate with the other you, which is over there, or maybe over there, but within a recognizable distance if we knew what we meant by distance. Hello, Arthur Dent here. Let's talk about dimensions, because sometimes you get these words mixed up. We talk about parallel worlds or other worlds, and sometimes we talk about them as being other dimensions. But actually, according to cosmology, there are more dimensions than we're aware of, but a limited number. Let's imagine what they are. Well, firstly, there's this way, backwards and forwards. Let's call that dimension 1. And then there's this way, to one side and to another side. Let's call that dimension 2. And then there's up and down. Let's call that dimension 3. And then, for about 100 years, we've been talking about the 4th dimension, which is time. Let's just put that to one side for a moment and consider these 3 dimensions. We imagine that if we walked along, say we're on a beach, and the sea was over there, which is in that dimension, and the sand is here, and the rocks were on the beach, and the pebbles were there, we'd be walking in one dimension, this way. Now, if we moved off to the side, we'd be going in the 2nd dimension, dimension 2. And if we raised ourselves up, jumped in the air, we'd be going in dimension 3. So, the puzzle for cosmologists is to try and imagine where dimensions 5, 6 and 7 are. And one of the theories is that they only exist at a very, very small space. They only exist perhaps at the molecular level. And if we had good enough instruments, we'll find them eventually. And what we'll find is they're kind of folded in on themselves. So we can't see them because even though they're down there, they're not really measurable. Isn't there an alternative? I mean, we call this dimension 1, and that's within our experience, right? What if that was dimension 5? And what if this, along here, we're calling it dimension 2, was actually dimension 2, but for all good purposes, it was dimension 6 as well. And this one up here, I'm calling it dimension 3. Maybe that's 7. Now, how would we know that they were there? Only if we could detect them. But we've got eyes that don't see everything. They see visible light. They don't see infrared. They don't see ultraviolet. They only see a narrow range. So perhaps that's one reason why we aren't aware of these dimensions. And the other reason is perhaps on the electromagnetic spectrum we're in the wrong place. I've seen a program recently which tried to suggest that maybe pigeons can find their way around the world because they see magnetic lines, not just where north is, but they see the lines of magnetism, and that's how they position themselves, and that's how they know that they need to go in a certain direction. So maybe those dimensions are there, we just have no way of measuring them. How would we even get an inkling that they were there? Well, we'd have to look for anomalies, wouldn't we? So in the example of walking along the beach, it might be that somebody says, you're walking along the beach, and they might say, you know, there's lots of crabs on this beach, crabs, and you look around and you can't see any. You see the sea, you see the pebbles, you see the rocks, and then as you're walking along, suddenly one of those rocks gets up and walks off. So it's not a rock, it's a crab. But our assumptions are that in this dimension we can see everything that's there. We can see the fact that this is sand, right? We walk along the sand. If the sand starts moving and a crab emerges from the sand and walks off in that dimension, we still say that's sand, don't we? That's not an anomaly. Even when the rocks start to move, we say, misunderstood. We thought they were rocks, but actually they're crabs. So we understand that. What if we were looking along dimension 1 and we saw a rock there, and then we turned away to do our examination of looking for dimension 5, which is down here somewhere at a microscopic level, and we're looking for that, and we turn back and we find that that rock that was over there is now here. Okay? Using our assumptions, we'd assume this is dimension 1, and therefore, in order for that rock to go from here to there, it must have moved in dimension 1. It couldn't possibly be anything else, could it? Unless it was dimension 5, because dimension 5 is possibly folded in on itself. Maybe it's here, we can't see it, but that rock moved through dimension 5 and ended up here. So for our purposes, because we're still thinking in terms of dimension 1, we don't notice that as an anomaly, because we assume that only things that we can see in this dimension are moving in this dimension, and they're not moving in any other dimension. And why is this even a possibility? Well, for one reason, when people try to take pictures of electrons, they not only have the problem that sometimes the point's there and sometimes the point's there, but when they take pictures, it seems to be as though there is a point that was there but is also there. And some people have said, perhaps what we don't realise is that the electrons are moving not only in 3 directions, this way, that way, and that way, but they're also moving within dimensions 5, 6, and 7. So maybe we're looking in the wrong place. Maybe instead of looking here for dimension 1 and then looking down here for dimension 5, we should be looking in the places that we already know for where those other dimensions are. Say goodbye to the Vogons. Now, when we talk about parallel worlds, we often get misled by things like that television series where the chap kept popping up in worlds that were very similar to ours, except that in one the Germans had won the Second World War, and in another one Abraham Lincoln didn't get assassinated and managed to pass Civil Rights Act, and in another one where Napoleon won the Battle of Waterloo, and so on. And the only problem with that is that we have this indulgence that we want to believe that in this parallel world, okay, there was this difference, but everything else is the same. And just like when we talk about ourselves being in parallel worlds, we imagine that we might be the person we are, except, I mean, I'm a crime writer. I write crime fiction novels. Although that's not actually true, what I write is science fiction novels disguised as contemporary crime fiction novels. But I won't go into that, just to let you know that reality is not always what it seems. But in these parallel worlds, perhaps I can imagine that I'm the person I am, but instead of being a crime writer, I am Prime Minister, or I am a Hollywood star in action films. Not very believable, but that could be possible. And what we want to believe also is that these worlds might be very similar, but slightly different. We don't want to believe, for instance, that I'm in a parallel universe where I'm a Hollywood star, except that in that parallel universe, nobody invented the movie camera. So what we want is a dream of how things could be different in our lives, things could be better. And what I found from 30 years plus of being a community development worker is most people want things to be better, but they don't actually want anything to change. Now, one of the ways they cope with that, for instance, is that they buy lottery tickets, because most people assume that if you won £10 million on the lottery, what would happen is you'd be the same person, except you'd be richer. And that isn't true. As we've seen from documentaries about people who do win the lottery, what happens is it changes their lives. And they find they have to move away because their mother wants a bigger house, or the neighbours keep coming round and asking for loans, or they go to the pub to see their mates, and the mates keep expecting them to buy the rounds, all of the rounds. Nobody else ever buys or pays for any drinks after their chap has won the lottery. And so what we have to get away from is this indulgence that says, okay, let's have parallel worlds, and in that world something could be different, like the Germans won the Second World War, but everything else is the same. Now hang on, if the Germans won the Second World War, I wouldn't be here. I was born in 1950. My parents would never have got married. So I can't be the same person in a different world, because I wouldn't be here, or I would have been educated at a German grammar school and perhaps learned different things apart from how to write science fiction. So it would all be totally different. Or if Napoleon won the Battle of Waterloo and reasserted his authority over Europe, then maybe in 1870 there wouldn't have been German reunification, in which case there wouldn't have been a First World War, let alone a Second World War. There wouldn't have been any Hitler, and so on. And we don't want to think this through. What we want is somehow to imagine that a parallel world is just a little bit different, but everything else the same. And quite clearly, that's totally contradictory. If there are these parallel worlds that have sprung off from ours and gone a different way, if they've gone down a different timeline, then yes, maybe the dinosaurs wouldn't have been destroyed by an asteroid, and some dinosaur would have turned into a biped and would have ended up looking very similar to the way we look today, and started a civilization, but we, the mammals, wouldn't be here. So I think we have to stop doing this thing where we imagine that the parallel worlds are a really good idea if we can live our dreams, if in that universe we can be important, or we can be rich, we can be something different from what we are now. The problem is we would be different, and that means we wouldn't be the same. Because if in a parallel universe I was a Hollywood star, I wouldn't be the diffident person I am today. I would be much more pushy and aggressive and forceful, and I would have a much better memory for learning my lines. Or if I was Prime Minister, I'd be much more politically aware, and I'd work long hours, and I'd go to endless meetings, and I'd go on television and distort facts to my benefit. So I'd be a different person. We can't indulge this fantasy of being exactly the same but better unless we also acknowledge the fact that if we were better, we'd be different. And what that means is our rosy glass view of parallel worlds isn't reality at all, even if parallel worlds are a reality. A final thought. If there are 5, 10, multiple worlds out there that are very similar to here, we need them to be different, maybe, in order for us to explain how those waveforms collapse to form a point that we would call an electron or recognize as an electron, but they be in a different position. There's another possibility. What if those worlds need to be in existence in order to make it possible that that waveform could collapse at a certain point? But what if in those parallel worlds what actually happens is that the waveform collapses at the same point? Now, there would still be multiple worlds. There would still be infinite possibilities that the waveform could collapse in any way at all. But what if those worlds were exactly the same as ours? Now, you might say, well, in that case, why do we need them? What is the point of adding complication to our view of cosmology? And the answer might simply be, well, if there weren't multiple worlds, we wouldn't have this solution to what happens with electrons when they form into a point, and we wouldn't be able to explain the rules and the mathematics that we've evolved, which seems to fit with just about everything else. So we might say, fortunately, there's half a dozen parallel worlds to ours, and that allows the possibility for this question of what happens to waveforms to be solved. And if it's the same argument that if that didn't exist, then we wouldn't exist, and this universe wouldn't be like it is. So it's not a question of, well, let's think about that, because it means redundancy. It means there are these extra worlds, and perhaps we could manage without them. Well, maybe we can't manage without them, which is why we've got them, but they're the same. And in that case, the person measuring this electron in this universe is the same as the other person in the other universe, and the other person in the other universe, and so on. Now, in order for those universes to evolve in parallel, in the same space, at the same time, with exactly the same things in it, there would have to be links, wouldn't there? Now we know that electrons can become entangled. So we'd have to suppose that if there were parallel universes which were exactly the same, then that would mean that everything in this universe, every waveform, every particle, every person, which was only collections of particles after all, every piece of wood, every piece of metal is entangled with the other universe, and the other universe, and the other universe. If there were 5, 6, universes, and they were exactly the same. The only way that would be possible is if they were linked in some way. And that, presumably, could be tested, because we know that experiments with entangled electrons yield certain results. What we need to know is whether other particles and other bits of our universe could be entangled, because in that case it might give us an insight into the fact that there are universes next door. Oh, great. If you're still here, congratulations. You made it to the end. Not many people have done that. Most people will have switched off very soon. You know why? Not just because they think what I was saying was nonsense, and some of it may have been. I'm not really sure about that myself. But they will have switched off because they'll realise that I wasn't wearing a white coat, and I didn't have the pens in my top pocket. And I didn't have glasses on all the time, as though I was studious. And I didn't have diplomas on the wall behind me. You know, we live in a very strange world where, on the one hand, everybody has an opinion about everything. Ask people about Brexit. They've got an opinion about that. Ask them about international economics. Well, if that means Brexit, they've got an opinion about that. They don't know anything about economics. They don't know anything about diplomacy, but they really think that the British government ought to start negotiating with Europe as soon as possible. They don't know anything about history, and they believe that we've got ourselves in this position in Britain where we're slaves to Europe, instead of actually being the senior partner that we were before we came out. So everybody's got an opinion, even with no qualifications at all. But when we see somebody on the television, we assume that because they're on television, they've got qualifications. We assume that because they're on Question Time, maybe they're a politician, maybe they're a comedian or a singer, but they've got authority and we need to listen to them. And if we're talking scientists, then they need diplomas on the wall, they need pens in their pocket, and they need a white coat. They don't appreciate that scientists could be wearing bathrobes. No, that's not usual. When we see people in laboratories, they're slaving over pipettes and test tubes and things are bubbling. That's what a scientist looks like. And then they come over to talk to you, they've got a white coat and they've got pens in their top pocket and they talk authoritatively. Now, what this program was about was I was trying to tell you that actually scientists don't have all the answers. And the good scientists realise that and will be happy to sit down and explain that to you. But not everybody's like that. I think it was Henry Ford who said, if my chauffeur has something to say to me about a Ford car, then I will listen to him. That was Henry Ford. And that might explain why he got to be so successful in making cars and got to be so rich, because he was prepared to listen. But the fact is, I'm willing to bet money, and I'm not a gambling man, I'm willing to bet that if any scientist ever saw that video that you've just been looking at, they would have turned it off in 5 minutes. Not just because what I said didn't make a lot of sense, but because I was the person saying it. Maybe if a colleague had made the same points while sitting in the canteen at the laboratory, maybe if they were at CERN in Switzerland and somebody said, you know this thing about parallel worlds, and had made a suggestion, they might be prepared to listen to it. But unfortunately, most people walk around with very closed minds. And you know what they say? A closed mind is as useful as a closed umbrella, even though sometimes it's not even raining.